first we're going to look at conversions. So that might be a little bit easier to see what I'm doing, what I'm working through on this whiteboard here rather than the one in class. So we're going to start with trying to convert 760 feet to meters. So in order to do that, this is actually English to metric conversion. So what I mean by that is feet is the English version, right? That's what we use in the United States for measurements of length, and meters is the metric unit. So we're going to use our conversion factor sheet that I have posted on Blackboard, or you can look one up as well. But to figure out what conversion factor we need, we're looking for one that goes between feet and meters. So we have a conversion factor on this sheet, in fact, under the length category, because feet and meters are both units of length, so that would be the area we'd want to search for when looking for an appropriate conversion factor. So we're going to start with the conversion factor that I found on here is 0.3048 meters is equal to 1 foot. So this will get me from feet to meters. So if you've watched the PowerPoints at all, you'll see that a conversion factor is written with an equal sign between it. So this allows us to write it as a fraction, and we can write it one of two ways. So the first way is where we keep the meters, we'll have it here in the numerator on top of the fraction, and put the foot portion in the denominator on the bottom. Okay? Or we can write it with the foot portion on the top and the meter portion on the bottom. So we're going to use it one of those two ways. How do we figure out which way? Well, we're going to start solving the problem. So once you have your conversion factor, you start what I like to call railroad tracks. And what this is like a plus sign. And what's always going to go in this upper left-hand corner is the number you started with, the number that you're trying to convert. So we're going to put in this upper left-hand corner that 760 feet. Now what goes in the rest of this conversion factor section is one of these conversion factors that we just wrote in fraction form. So how do we know which representation is going to work best here? Well, in order to figure that out, we're trying to cancel feet, right? We're trying to get rid of the feet, and we're trying to keep or convert to meters. So the one that's actually going to work is going to be this first set. So how do I know that? Well, because this horizontal line that we have here is actually a division line. The vertical line, multiplication. Okay, so if this horizontal line is a division line, and I take this, so imagine picking this up and setting it here. I take this version of that conversion factor and put feet on the bottom. What I have now is feet divided by feet. So since I have feet on both sides of that horizontal line, they actually just cancel each other out. So I want the feet portion on the bottom because I'm trying to get rid of that. I'm trying to convert to meters. So the feet portion canceled, leaving me with just meters as my only unit. So I'm going to go ahead and solve this. So to solve, remember that vertical line was a multiplication sign, so I'm going to multiply across, and I'm going to get 760 times 0.3048. And divide that whole thing by 1. Now once you calculate this, you want to check back and make sure that you're reporting your answers to the correct number of sig figs. What I get from my calculator is 231.648. Okay, so we need to look and see how many significant figures. So to figure that out, we're looking at just the original number in the question that said take this 760 feet and convert it to meters. Okay, so that's the only number we're taking into account. We're not using the sig figs and the conversion factors. Okay, anything you get out of this table are not going to be factored in for sig figs. Just the number in the question itself. So looking at this, we start counting at the 7, the 6 also counts. But in this case, this 0 after the 6 is not going to count. So the reason it doesn't count is twofold actually. Zeros can only count if they're in between two non-zero numbers or if there's a decimal point. And we have neither of those, meaning that 0 does not count. So I have 2 sig figs here. That means I want just 2. So I'm going to do the 2 and the 3. Always look to the number next to it. Does that stay at 3 or do I round up? In this case, it stays. So a lot of students will make this mistake and stop there. 23. Okay, this is actually incorrect. Yes, it's 2 sig figs, but the reason it's incorrect is because notice our original number was 231, so in the 200 range. I can't go from 200 down to 23. I need to still stay in the 200 range. So to do that, what I'm going to do is I need to add, put a number here in place of this 1, but that number can't be significant, so kind of like a placeholder. So what's the only number that I can use that won't be significant here? It won't count as a sig fig. 0. 0 is the only one that sometimes doesn't count, and as long as I don't put a decimal point on the other side of that 0, it will not count, and I'm still sticking with 2 sig figs. Okay, so 230 meters, don't forget to put the units, is going to be the correct answer with the correct amount of significant figures. Okay. Trying to find that little eraser here so I can work on another problem. All right, let's try another one. Next we're going to do gallons to liters. So we just did a length conversion, now let's do volume. So say we had 38 gallons and we want to know how many liters. So to figure that out, we need a conversion factor. And I know this because gallons is English unit, liters is a metric unit. So I'm going to use my English to metric units. I'm going to look in the volume area down here because gallons and liters are both units of volume. And what I find is a direct conversion going from liters to gallons. And that is the 3.785 liters is equal to 1 gallon. Okay. So remember, you can represent that conversion factor in 2 ways. With the liters on top, gallons on bottom, or with the gallons on top and the liters on bottom. So let's start our railroad tracks and see which one we're going to need. So when I do my railroad tracks, I start with the number in the question. It's going to start it off up in this upper left-hand corner. Now I need to figure out which one of these I'm going to use here. Now remember, I'm trying to get rid of gallons. So I'm going to want to pick the one where gallons is in the denominator. So this guy here. Put that 1 gallon in the denominator, the 3.785 liters up in the numerator. Since gallons are on opposite sides of that horizontal line, it's going to cancel out. And what we're going to get is, I'm going to multiply across, so we'll get 38 times 3.785, and divide that by what's in the bottom, the denominator, which is just 1. Oops, didn't put my units there. So, it's going to give me 38 times 143.83. Remember, we've got to look for significant figures, so let's go up to our original number. There are just 2. So I want just 2 in my answer. So this is similar to that last one we saw. I'm keeping just the 1 and the 4. I look to the number next to it. It's going to stay a 4. So I have 14. But notice this was 143. So instead of bringing that 3 down, which would make an extra significant figure that I don't want, instead I'm going to change that 3 to a 0. Because 0 is the only number I can put there as a placeholder that won't count as a significant figure. So now that I have the correct number of sig figs, I want to add my units. So 38 gallons is equal to 140 liters. Let's do another one. So let's now do 0.526 kilograms. We're going to convert it to ounces. So we're going to be a little more in depth. It's going to be a few steps. So I'm doing mass, kilograms and ounces, so I'm going to look for some conversion factors in here. And when I'm looking for the conversion factors, I have 2 that have kilograms in it. One is going to pounds, and the other is going from kilograms to tons. Okay, so I'm going to write down the ones going to pounds. Yeah, it's not getting me to ounces, but it's getting me to at least a different unit that might get me to ounces eventually. So I'm just going to write it down off to the side here. So here are my conversion factors over here. 1 kilogram is equal to 2.205 lbs. Okay, so let's write a chain here. So if I have kilograms and I use this conversion factor here, that's going to get me to pounds. Conversion factor number 1. All right, so once I'm in pounds, can I get to ounces? So I'm looking again. Well, the conversion factors I have here, I only have one conversion factor that has pounds in it. Okay, and that will get me from pounds to grams. So I'm looking at the one that says 453.6 grams is equal to 1 pound. Okay, so that's going to bring me from pounds to grams. So this is going to be a couple steps. One of the hardest ones you'll see. All right, I'm still not at ounces, but now there's hope because there is a conversion factor that goes from grams to ounces, and that is 28.35 grams equal to 1 ounce. So we have 3 different conversion factors. This third one is going to get me to the ounces I desire. Okay, so we're going to go from kilograms to pounds using that first conversion factor. That'll put us in pounds. Then we're going to get from pounds to grams using the second conversion factor. The third conversion factor will then get us from grams to ounces. So a couple different steps. Let's start the railroad tracks. So how we're going to start this problem is with the original number in the original question. That's going to be that 0.526 kilograms. So our first step is we're going to go from kilograms to pounds using conversion factor 1. I want to get rid of the kilograms, so when I use this conversion factor, I'm going to put the kg, the 1 kilogram, on the bottom. So they're on opposite sides of that horizontal line, and they will cancel each other out. If I stopped here and did this calculation, I would now be at pounds. But I'm going to keep going and get to grams. And I'm going to do that by using the second conversion factor, which goes between grams and pounds. So now I need to figure out, do I want the pounds on the top or the 1 pound portion on the bottom? And since I'm trying to get rid of the pounds, I'm going to put the 1 pound portion on the bottom, leaving the gram portion on the top. So the pounds now cancel. If I did this calculation, multiplying those 3 together, I would be at grams. I'm going to keep going with one more step and this last conversion factor to get me to the ounces. So using this conversion factor, do I want the grams on the top or on the bottom? Remember, I'm trying to get rid of grams, so I'm going to want it on the opposite side of that horizontal line. So down here in this case, it's going to put my 1 ounce on the top. Grams are on opposite sides, so they're going to cancel. So now I calculate this all out. Remember, those vertical lines are multiplication signs. So I'm multiplying 0.526 times 2.205 times, I'm going to run out of room, 453.6 times 1. All of that in the numerator, and then in the denominator, it's just 1 times 28.35. So let's see what we get when we enter all this in. And if you see any mistakes, I mean, it's very likely once in a while I am going to press the wrong button on my calculator, especially if I'm talking while I'm trying to calculate. So please point them out so I can alert everybody, make sure everyone's on the same page. All right, so I'm getting 18.55728. Okay, but I don't want all of those numbers. I want just the significant ones. So to figure that out, I'm going way back up here at our original number. This first 0 does not count. We can't start counting till we get to our first non-zero number, which is the 5. The 2 also counts, and the 6 counts. So we have 3 this time. So 1, 2, 3. Always look at the number next to it. 5 or higher in this case, so that 5 is going to round up to a 6 to get us 18.6, and the units on it are ounces. Okay, so that's probably the hardest type we'll see. Let's now look at metric to metric. So far, all we've done is English to metric. And I've known it's English to metric, basically because I just can recognize. Ounces is what we use here in America, kilograms is what they use in Canada and other countries, okay? So that's one way that I've been able to tell they're all English to metric. To figure out when you're approaching a conversion problem, if it's metric to metric, I'll show you a trick on how to do that. You're going to have a letter in common. It's going to be going from kilograms to milligrams, or from centimeters to millimeters. Okay, so they're going to have that last portion, that last word, letter in common. So looking at metric to metric. So when we're calculating metric to metric, we're going to be using this scale that I talked about in the PowerPoints, this KHD space DCM. And what that is it's the prefixes for the metric system that we're going to be looking at in this class. So we're only covering a small spectrum of the metric to metric prefixes. This first one is kilo, then it's hecto, deca, deci, centi, and milli. So you're going to want to remember the ordering of these prefixes so that you can write this scale down, because we're going to be using this to convert from metric to metric. Now, there are some mnemonic devices to help you remember this. One that you might have heard before is King Henry died drinking chocolate milk. The one I used in the PowerPoints was kiss her dummy, blank, don't chase me. So we're going to be using this to figure out how to convert. Now, the nice thing about metric to metric is we're actually just moving the decimal. So this scale will help us figure out how many times to move the decimal and in what direction. Okay. So let's talk a little bit about what this blank, this empty space is before we do that. So that empty space, you're going to fill that in depending upon what you are measuring. So what I mean by that is if you're measuring length, what's going to be in your empty space is m for meters, because in the metric system, meters is the base for length. If you are measuring volume, you're going to put an L for liters, because liters is the unit of volume in the metric system. For mass, you would use grams, put a G there. If you were talking about time, you would use seconds, put a S there. Okay, so depending upon what unit you're measuring, you'll fill that in accordingly. Okay, because this scale can be used for all of these units of measure. All right, so let's look at a problem and apply. So if I'm taking 0.35 kilometers, and I want to know how many meters that's going to be. Okay, so to do that, I'm going to use this system up here. But in order to use this, I need to first fill in my blank. Now, the reason I know this is metric to metric and that I can apply this is because of that letter in common. Okay, so this only works for metric to metric. You couldn't use it if you were going from pounds to ounces, for instance. Since I have that letter in common, it tells me, okay, yes, I can use this scale. It's a metric to metric conversion. And it also tells me that letter in common, that's what's going to go in my empty space, because I'm talking about length, and length is measured in meters. Okay, now don't get this middle M confused with the M on the side. Remember, this was milli, like millimeters, really, really tiny. All right, so how do I convert now that I have my chart ready? Well, now what you want to do is look at what you're starting. So you're starting at kilometers, which means you're going to start at the K. And where are you going? To the meters, this M here. So to figure out how to convert, you just move until you get to that M. However many times you move, that's how many times you're going to move the decimal. Whatever direction you move, that's the direction you're going to move the decimal. So if I start at the K and have to go to the M, I need to move once to get to the hecto, twice to get to the deca, and 3 times to get to the meter. What direction? Well, we went to the right. So I'm going to do the same thing here. Let me write this number again so it's a little bit more clear. So I have 0.35. I'm going to start at the decimal, and I'm going to go 3 times to the right. So 1, 2, 3. So here's where my new decimal is going to be. What's going to go in that empty space? A 0. So 0.35 kilometers is equal to 350 meters. Notice I kept the correct number of sig figs as well. There are 2 sig figs in this number, and I still have 2 because that ending 0 does not count. All right, so let's try another one. So the next one we're going to try is going from milligrams to grams. So the problem is going to be 500 milligrams. So say you had to take a 500 milligram dose of some medicine. And you wanted to know, okay, how many grams is that? So to recognize it as metric to metric, we're looking for a letter in common. So I have G and G, grams and grams, milligrams to grams. So that means G is my base. I'm measuring mass this time. So how many times do I have to move the decimal? Well, I'm starting at the M, the milligrams, and I'm going to the G. So this time, notice I'm going to move my decimal to the left. How many times? 1, 2, 3. So 3 times to the left to get to grams. In the number 500, I don't have a decimal there. So when I don't have a decimal, where do I want to start? I'm going to start at the end of the number. 1, 2, 3. So my new decimal is going to be in front of the 5, and I am going to get 0.5 grams for my answer. So notice I did not include the zeros because the original number didn't have a decimal point in it. Right? We had to just put it at the end in order to move it. So if there's no decimal point in it, those zeros don't count. So I don't want to include them as part of my answer. Let's try one more. So this time we're going to go back to measuring length, and we're going to convert 12,500 500 centimeters to hectometers. So this time, what is our base? What's in common? That last letter, the M and the M, meters. So that's what's going to be going in that empty space, an M for meters. So how many times do I need to move the decimal? Well, I'm starting at the centi, the C, and I'm going to hecto, the H. Remember, each one of these letters counts as one spot to move the decimal. So I have to stop at each one and count. So deci will be 1, meters would be 2 times, deca would be 3 times, and then hecto is going to be 4 times. So I need to move that decimal 4 times to the left. Once again, I have a number with no decimal point at the end. So I'm going to add 1 so that I have something to move. So I'm moving it once, twice, 3 times, and then 4 times. It's going to get it between the 1 and the 2. Now, I originally didn't have a decimal point at the end, so remember, those zeros aren't counting towards my sig figs in the final number. So I'm just going to put 1.25 stopping there. My new units, HM or hectometers. All right, there's another one on the PowerPoints going from seconds to milliseconds, and I show how to do that one on there. So I'm going to skip that one here since it's already on the PowerPoints, but I am going to do one more that is combining English to metric and metric to metric. So let's look at that. So 600, notice this one's going to have a decimal saying that those zeros matter. That's why the decimal's there. And it's going to be millimeters, and we're going to go to inches. So when you first approach this problem, you're going to see that you're going from millimeters to inches, and you're going to look and think, okay, it's metric to English, let me find a conversion factor, and that's good. Okay, but then when you go to look, oops, excuse me, you'll see that in the length area, because that's what we're measuring is length, there are absolutely no conversion factors with millimeter in them at all. Okay, so how would you solve that? Well, if you can't find one going directly from millimeters to inches, can you find one that's in the metric area? Okay, and you can. There's a couple of them actually. One that would really help has inches in it, and then a metric unit, centimeters. So I'm looking at the very first one on this conversion factor chart. So if I have or use this 2.54 centimeters equals to 1 inch. So in order to use this, what I need to do is go from millimeters to centimeters. So let's write that process. I can go from millimeters to centimeters using my scale, because this is metric to metric. And then I can get to inches using this conversion factor. So this step is going to be my conversion factor step that I found in the table, going from centimeters to inches, centimeters to inches. This first step, I'm going to move the decimal because it's metric to metric. So let's do this step first. So this is where I need to know that scale, the KHD space DCM. Okay, and I'm taking the number 600 millimeters, and I'm trying to get it to centimeters. So to do that, it's going to go in my empty space, meter, meter. So we're going to put an M there. And we're starting at the millimeters, and millis down here. Okay, the middle's meter, the end is millimeter. So this is where we're starting, and we're trying to get to centimeters, the C, right next door. So we're just moving the decimal point 1 time to the left. That's it. So I'm going to start at decimal, move it 1 time. So that's going to get me, I'll write it over here, 60.0 centimeters. So I'm here. at centimeters. So now I can use my conversion factor, do my railroad track method to get from centimeters to inches. So taking this conversion factor, I need to figure out what goes on top, what goes on bottom. Do I want centimeters on top or centimeters on the bottom? I'm trying to get rid of centimeters, so it's going to go on the bottom. And then my inches is going to go on the top. That way centimeters cancel. So to figure this one out, I'm taking 60 and dividing it by whatever's on the bottom, in this case, 2.54. So that gives me, I'll write it down here, 23.622 blah, 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 a whole bunch of numbers. Okay, well, how many sig figs do we want? Let's look all the way back at the original number. This time there is a decimal point at the end of the number, so it's telling me that not only that 6 counts, but the zeros count as well. That's why the decimal's there. So we want a total of 3 significant figures. So I'm going to go 1, 2, 3. Look at the number next to it. It's going to stay a 6, so 23.6 inches is going to be my final answer. All right, so we've covered conversions, English to metric, metric to English, combo of both, metric to metric. So seeing all the types of conversions we're going to cover in this course. What we'll look at next time is percent error and density, which will round out chapter 1.